All right, good morning, everyone. Today we are going to look at a topic, position, distance, and displacement. Can you hear me? I hope you can hear me. Welcome to today's live stream. Okay, we are going to look at position, distance, and displacement. All right, so let's proceed. Position can be defined as a point at which an object can be found or what? Located, right? Now, if we can able to locate where an object is found, we can say that we know the object position. How do I mean by that? If we use this four cardinal points to express it, we have, okay, now if an object, this is a mango tree, okay, and an object is here, somebody that is here can also locate this object. For example, using these four cardinal points, we have north, east, south, and west. How do we locate the object? We can actually know it based on the what? The position. If they say that the object is north 60 degrees what? East. How do we locate it? So we just from this four cardinal point, this is north, we go this way, we measure 60 degrees, we can now go and locate what? The what? The object. Okay? So in a nutshell, we now concluded that position is a point at which object can be found or what? Located. All right. Okay, let's see people that are joining us for the class. Now, an object can be found on a plane or in space. What is a plane? A plane has just two coordinates, for example, x and y. So, an object can be found in a plane or in space. Okay? Now, a plane has just two coordinates. I will say a plane has two coordinates, that is x and y, right? A plane has just two coordinates, x and y, so it means it has x axis and what? Y axis. Then space has three coordinates. The three coordinates is, we have x, y, and what? Z. So a plane has just two coordinates, x and y. Y space has just three coordinates, x, y, and z, right? Then we should not forget that the s coordinate is called abscissa. Okay? Then y coordinate is called ordinate. Okay? Okay, so let me summarize what I have. Position is defined as a point at which an object can be found or located. And I said, if you're able to know the location of an object, that means you already know what? The position. And I also said we can use a bearing method, which is the four cardinal point method, to locate an object. Okay, and I said that we can use the bearing method, which is the 4 cardinal point object, to locate an object. For example, using north, east, south, and what? West. If the angle is noted, we can easily use it to get the position of what? An object. All right. Then I said an object can be found in a plane or in space. What is a plane? A plane is characterized by 2 coordinates, which is x and y. Okay, so anything that is done on a plane is have x and y, and this is y, this is what? X. So this is what I mean by x and what? Y. Then space has 3 coordinates, which is x, y, and what? Z. Okay, then the x coordinate is called abscissa, while the y coordinate is called ordinate. I hope you understand it. So you're going to see how we can use the plane to get the position of an object if it is being specified. And most times objects hardly cannot be found in what? In space, because space has 3 coordinates, which is just like this. This is this is y, this is s, and this is what? Z. Hardly will you see an object found in what? In space. But most times we use plane because they have just two coordinates, which is x and y. So let us see how we can locate an object using the what? On the plane axis. All right. I said if you use these 2 coordinates, we can certainly get the position of an object. For example, I have this. This is positive y and negative y, and this is positive x and negative x. Now, if you have this, how can you locate an object? For example, too, if they said an object A has this coordinate of -3 and what? 5. One thing must come to your mind. What is that one thing? That this is x and this is what? Y, right? Now, how do you locate this object? You already know that this x has what? The negative. This x is the negative side, while y is the what? Positive. So I'm going to look at negative x and positive what? Y, right? So we already have this quadrant to use and locate this object what? A. If I want to sketch it, I will say that this is this and this is this. So this is y and this is minus what? X. This is my point of origin, which is 0. So I'm going to number it so I can be able to locate that object A, right? This is what? 1, 2, 3, 4, and 5. Why this is -1, -2, -3, -4, and -5. Now, if you have gotten this, the next thing you are going to do is to look at it. When x is -3, y is what? +5. So I will say when x is -3, I will take it up from -3 because x is negative. Then I will meet it to where y is what? 5. They are going to meet each other. That is the point of intersection here. Then I'm going to join it to the origin. Okay? Now this is the object what? A. I'm able to locate this object. I hope you understand. So if you're asked to locate any object, you're going to first know whether is it negative or is it what? Positive. And remember, I said most times you locate an object in a plane because it has just x and y axis. It has just 2 coordinates, positive and what? x and y axis, sorry. Okay, so this is how we can locate this object A. All right, so I'm going to do another illustration how to locate another object. Now, remember, I must make respect to this so that you will not mistake it for another thing. This is plus y minus y plus x minus x. Now, how do you locate an object? I will say an object P has coordinates of, let me say, -2, -4. Okay, one thing that will come to your mind is this. This is x and this is y. So x is on the negative and y is on the negative. So we use this quadrant. This is minus x and minus y. So I'm going to use this quadrant to locate my object P. Okay, you're getting it. So in that case, I'm going to have this and this. Okay, now this is my minus x and this is my what? Minus y. This becomes my point of origin, which is 0. So remember, you have to start from 0 to number it down. Don't start from here to number it this way, okay? So if I start from here, I will have -1, -2, -3, -4, -5, okay? I will number this one as well. I have -1, -2, -3, -4. All right. Now, from the question, x is -2. Look at -2 here on the x-axis. I will follow you down. Y is what? -4. I will follow you down and meet this y when it is -4. The point of intersection, I will join it to the origin. Then I'll call the point what? P. So this is how we can locate the position of any object when they are given to us. So I'm going to give you this problem to see if you can be able to locate the object. Then I will solve it in the next few minutes. Okay? So I will say locate an object H, which is giving us 5, -1. So I want you to locate the position of this object 5, -1. In the next few minutes, I'll come back to solve for it. Oh, thank you for joining us, Osapo Kechiku. I'm really happy. Thank you so much. Amara Precious, thank you for joining us. Cave of Adulam, sorry for not saying it well. Thank you so much for joining us. Onyeka Nakoze, thank you for joining us. I really appreciate. Neki Odum, thank you so much for joining us. I really appreciate. Please give this live stream a thumbs up. Please give it a thumbs up. I really appreciate. Thank you so much. God bless you for joining me. I really appreciate it. Thank you so much. All right. Now we can, let me solve this. I've given you for you to work on it, but let me solve. The first thing that will come to our mind is this. This is x, and this is what? Y. Okay? So this is x and this is y. It just means that x is positive and y is what? Negative. So I'll come back to this and see that x is what? Y, right? Don't forget that x is plus here, y is minus. So this is x and this is y. So I'm going to use this quadrant to locate this object h, right? Okay, so I'm going to go this way. This is my point of origin. This is my x, and this is minus y. So remember, you have to start from your origin O to number it this way. Okay, so I will have 1, 2, 3, 4, and what? 5. Now I will have here minus 1, minus 2, minus 3, minus 4, and minus 5. Okay, so what do we have? When x is 5, what is my y? Minus 1. So I'm going to go this way. This is, I will go down, plus 5, and this is what? Minus 1. Remember, the point of interception, you are going to join it to the origin to be able to locate that object h. So I will join it, then I have this. So this is my object, what? H. So that is how we can locate an object. We can also use a bearing method. You know what I mean by bearing method? So I'm going to give you illustration of bearing method. The bearing method, we are using the 4 cardinal point, which is we have north, east, south, and what? West. Okay, so if we are asked to locate an object at north 60 degrees what? East. Okay, how do you locate this object? If they say north, you start from north and go what? Eastwards. You start from north and measure angle of 60 degrees and go eastwards. So let me explain. So I have this. This is the 4 cardinal point. Okay, this is north, east, south, and west. So I'll from here measure angle of 60 degrees. Then I'll go this way. All right. So this is what? 60. And if this is 60, here becomes what? 30. Because each of the quadrants has an angle of 90 degrees. So if I measure out 60 here, I'm left with what? 30. So this is the position of the object indicated. Do you understand? So, for example, your angle given of an object is south 45 degrees west. It means I'm working with south and what? West. I'm working with south and what? West. So if you draw your 4 cardinal points, you're going to start with what? You're going to start with south. This is what? West. And you go which way? You go this way. Measure 45 degrees, right? This is where the object is what? Located. Do you understand? And if here is 45 degrees, here is also left with what? 45 degrees. So I'm able to explain to you how we can use ordinary method, which is XY coordinate, to get the position of an object when specified. Now, this is also bearing method to also get the position of an object using angle. I hope you understand the two methods now. So this is how we can get the position of an object. And that, don't forget that this position is where an object can be found or what? Located. And an object can be found in space or in plane. Do you understand? And I also said that space is characterized by three coordinates, x and what? Y. Y plane is characterized by two coordinates, space is characterized by three coordinates, x, y, and z. Y plane is characterized by two coordinates, x and y. All right, so let's move to the next concept of the topic, which is distance. Now we can say that distance is defined or can be defined as the gap or separation between 2 points. 2 points, and a point must have x and y or x, y, and z axis. Okay. For example, I have point A and I have point B, right? The gap or separation between them is what is said to be what? Distance. Okay. Now, this point will have x and what? Axis. This also point will have x and what? Axis. Now, this point can also have x, y, and z. Can also have x, y, and what? Z. So we can able to locate our distance between a point. You understand? Now we can conclude that distance is the gap between 2 points. Okay. So let us say a few things we have to know on this distance. Distance is measured in meters. Okay, so we can say that the units of distance is meters. Distance can be found on a plane or in space. And don't forget that a plane has two coordinates, x and y, while space has three coordinates, x, y, and z. Okay, so now in physics, distance is denoted by x. I will say in physics, distance is denoted by what? By x. Now I'm going to show you the formula for us that we're going to use to find distance in plane and also what? In space. Thank you so much. Please give this video a thumbs up. I really appreciate. God bless you for following this live stream. I really appreciate. God bless you. So let us look at the formulas that are going to help us, or are going to generate to use to solve problem for distance in space and also in a plane. All right. So let's clean the board. For plane, x is equals to s2 minus x1 all squared plus y2 minus y1 all squared. They will take the root of it. This is for what? For plane. And remember that plane has just x and y what? Coordinates. Okay? Then for space, x is equals to root of s2 minus x1 all squared plus y2 minus, y1 all squared plus z2 minus z1 all squared. This one is for space, because space has what? X, y, and z. And remember, if I say distance is a separation between 2 points, a point has, if it is on a plane, a point has both x and y axis. Then the second point has both x and y axis. Okay, so this is how we can use it to solve problem on distance. So let's look at a few examples of how we can use this formula to generate the distance covered between 2 points on a plane and also in space. Let's look at example 1. Calculate the distance between the points A, comma 2 bracket 3 and B, comma minus 5, comma 1. Now, looking at this question, we can now see that this distance we are looking for is on a plane, because it just have x and y axis, right? And I told you that the first letter here is for x. Why this is what? Y. When I did position, so x is usually come first before what? Before y. So this is the first point A, and this is the second point A. So what I'm going to have here, this is my what? X1, because this is the first point, and this is what? Y1, this is the second point. Okay, so here is what? X2, and this is what? Y2. Now, if you're going to use this formula for distance on a plane, so you're going to say that, let me just simplify it well. X1 is equals to what? 2. Okay, Y1 is equals to 3. S2 is equals to minus 5. Y2 is equals to 1. I think that is okay now. I have brought out everything and specified them. The first point, everything I have under the first point is 1, even if it's in space. So we have this is 1, 1, and the other one. That is if it's in space. So the formula I'm going to use for this x is equals to root of x2 minus x1 all squared plus y2 minus y1 all squared, right? So we are going to proceed. What is my S2? Minus 5. I will say minus 5 minus. What is my S1? 2, right? I'll put all squared. Then plus, what is my Y2? 1. I'll put the minus. What is my Y1? 3. I'll put 3. All squared. Hope you are following. Alright, so I'll bring it down and do the mathematics. Minus 5 minus 2 is going to give me minus 7 all squared, right? Then plus 1 minus 3 is going to give me what? Minus 2. So I have minus 2 all squared. All right. So remember, when you want to square a negative sign, the negative will disappear. It will not affect whatever thing we are doing. How do I mean? If I say minus 7 squared, it is the same thing as saying minus 7 times minus 7, right? Minus times minus is what? Plus. 7 times 7 is what? 49. So if I say root minus 7 all squared is 49, I believe I'm not wrong. So this is how we do it. All right? So this is x is equals to, this will give me minus 7 all squared is what? 49 plus minus 2 all squared is what? 4. All right. So I'm going to add it together. 49 plus 4, I'm going to have 53. So with the help of calculator, we are going to say root of 53. Root of 53, which is x, is equals to, the root of 53 is going to give me 7.28 meters. So when you find the root of this 53, you're going to give me 7.28 meters. You know why I'm putting meters? Because distance is measured in meters. So this is how we can get the distance of an object on a plane. Okay? Using the formula, substitute it in what you have. Remember that the first point has x1 and y1. And the second point has x2 and y2. So just bring it out and bring all out. Then state the formula and carefully substitute it into what you have. And use your knowledge of mathematics to bring it down and find the root with your calculator. That gives you the distance of an object on a plane. I hope you understand that. Okay, so I'm going to look at another example. Okay, so let's solve another example. That is example 2. Let's go to the next one. All right. We're going to look at calculate the distance between the points C in bracket 2, 4, 6. Okay. Then and D in brackets -5, 3 and -4. All right. Now, what I'm going to do now is to state what I want. This is the first point. This is the second point. So this one that is the first point is S1, Y1, and Z1. This is on the plane because they have X, Y, and Z. So this is the second point, S2, Y2, and Z2. Right? I'm going to use the formula for space. And X is equals to root of S2 minus X1 all squared plus Y2 minus Y1 all squared plus Z2 minus Z1 all squared. Now, if you have gotten this knowledge, you just have to substitute it into what we have. What is my X2? My X2 is -5. I'll just say -5 minus my X1 is what? 2 all squared, right? Plus my Y2 is 3. 3 minus my Y1 is what? 4. Okay? All squared. Plus my Z2 is what? -4 minus my Z1 is what? 6 all squared. So let us work it together by saying X is equals to root of, what is this? I have -5 minus 2 is going to give me what? -7. I have -7 all squared plus 3 minus 4. I'm going to get -1. Okay? All squared. Then plus -4 minus 6 is going to give me what? -10 all squared. Remember that if you are squaring a negative sign, the negative sign will disappear because it has no effect on what we are doing. All right? So I will say this is root of, this is what? -7 squared is going to give me 49 plus -1 squared is going to give me 1 plus -10 squared is going to give me what? 100. Now I have to add them together. 49 plus 1 is 50. 50 plus 100 is 150. So I have X is equal to root of what? 150. Okay? So with the help of calculator, I will say root 150 is equals to, so the answer will be 12.247, but I'm going to approximate to let it be in 2 decimal places. So X is 12.25 meters. So the distance between this object in space, which is C and D, is equal to what? 12.25 meters. And don't forget that this distance is a scalar quantity. A scalar quantity in the sense that it has only magnitude with no direction. We can find the magnitude, which is this distance we just calculated, but we cannot specify whether it's going north or it's going east or it's going south. I hope you understand. So I'm going to give you another example or another classwork for you to see if you're going to be able to solve the distance between 2 points. Okay, let's see people that are joining us. Hi, Mr. Matthew Okechukwu, God bless you for joining us. Nerida, God bless you for joining us. KBS World, thank you for joining us. I really appreciate. God bless you. I really appreciate. Chibus Otochukwu, thank you for joining us. God bless you. Please give this video a thumbs up. Please like this live chat, please. Thank you so much. Okay, so I should write boldly. Okay, so I'll take note of it. Thank you so much for joining. I really appreciate. So let's look at another example. I will give you this one to try. In the next few minutes, I'll solve the solution to it. The position of an ant and a spider in a room are A bracket 2, 3, 5 and X bracket 6, 0, 8. And the question is, determine the distance between ant and spider. So I'm going to give you a few minutes to be able to solve this. I'll come back to do the correction. Okechukwu, Matthew, S stands for distance. S means distance, okay? In physics, we denote distance with letter X in physics. Jamie Valan, hi. Thank you for joining. Thank you for joining. I really appreciate it. Thank you for joining. Yesu, BBR, thank you for joining. I really appreciate. Okay, I'm coming from India. Wow, thank you so much. Thank you for joining. All right, we can solve this problem because looking at it, they said the position of an ant and a spider in a room are 8 bracket 2, 3, 5 and x bracket 6, 0, 8. How do we get the distance between the ant and the spider? Certain, looking at this coordinate, they have just 3 coordinates. So this is x, y, and what? Z. So this is in space. Okay, so what I'm going to do is I'm going to state it by saying the first value is 2, 3, 5. Okay, all right, and the second value x is what? 6, 0, 8. Now what we are going to do is to state it. This is the first point, this is the second point, and for the first point, this is my what? X1, Y1 and Z1. This is my second point. I have X2, Y2 and Z2. Now I'm going to use the space, and the formula for space, x is equals to root of x2 minus x1 all squared plus bracket y2 minus y1 all squared plus, okay, I have z2 minus z1 all squared. The next thing I'm going to do is to substitute it into what I have. Okay, so let's go. I have my root. What's my s2? My x2 is what? 6. So I put my bracket. 6 minus my x1 is 2. 2 all squared plus my y2 is what? 0. Okay, minus my y1 is 3. All squared plus my z2 is 8 minus my z1 is what? 5 all squared. And the next we are going to do is to use our knowledge of mathematics to work it out. Okay, so this is 6 minus 2 is going to give me 4. So I have bracket 4. Okay, I have just 4 all squared plus 0 minus 3 is minus 3. I have minus 3 all squared plus 8 minus 5 is going to give me 3. So I have 3 all squared. Right. So let's work it out and get the final answer. Okay, so I'm going to break it down by saying x is equal to root of minus 4 squares is the same thing as saying 16 plus minus 3 squared is what? 9, because I told you that squaring a negative sign has no impact on our square. Okay, so I have again plus 3 squared is what? 9. So I'm going to add them. With the help of calculator, I will say 16 plus 9 is going to give me 34. So this is root of 34, right? Then we are going to use our calculator to find out the root of 34. I'm going to have 5.830, okay? Approximately 5.83 meters. So this is how we can generate the distance covered by this object, right? This object, ant and what? Spider. With this their coordinates. So knowing that this is in space and space has just three coordinates, x, y, and z, right? So remember the formula: x squared minus x1 all squared plus y squared minus y2 minus y1 all squared plus z2 minus z1 all squared. Then we find the root of whatever we have. Remember that the first point here, this is x1, y1, and z1 because this is the first point. Then for the point, x2, y2, and z2, right? After that, we're going to substitute it into what we have by saying anytime we see x, where this is 6, I'll put it here minus. Okay, I'll put it here square plus. When you substitute everything, remember if you are squaring a negative sign, the negative sign has no impact on whatever thing we are doing because it's as if you are saying minus minus is what? Plus, right? So this is how we can solve this problem. All right, the next concept you're going to look into is what? Displacement. Okay, all right. We are going to change it to three decimal places. Yes, most times at the final answer, it is mainly left in, except the examiner will specify whether you are going to convert it to three decimal places. But then I prefer most of the answers to be in two decimal places. Just a minute. Okay, the next we are going to look at now is displacement. And displacement is defined as the distance covered in a specified direction. So how do I mean? Let us state it clearly. Displacement is defined as the distance covered in a specified direction. The unit of displacement is meters. It is a vector quantity. Now, there is a difference between displacement and distance. Distance, you can just get the magnitude the way we use space and planes to get the magnitude. But displacement, you must certainly tell us where it's going, whether it's going east, north, or what, or south. So in displacements, we must specify where the object is going. And most times we use the four cardinal points to denote it. And remember the four cardinal points: north, south, east, and what? West. We use the four cardinal points to denote the displacement of an object because it's a vector quantity. When we solve for the magnitude, we as well solve for the direction. So let us see and get the displacement of an object. All right, let's look at this question. Please, if you are joining us now, give this live stream a thumbs up. Please give it a like, please. Please, God bless you. I really appreciate it. Thank you very much for joining. Okay, let's solve this problem together. A boy walks 3 kilometers due east and then 4 kilometers due north. Calculate the displacement of the boy from its original position. Now, this question was specific. They specified the direction in which the boy was moving. And I told you that displacement is a distance covered in a specified direction. So it means that of this boy to be able to get the magnitude and direction of this boy, because displacement is a vector quantity. It has magnitude as well as direction. So how do you do this? You say You draw the 4 cardinal points. Okay. Okay, let me draw a bold one so that you can see it clearly. This is north, west, south, and east. Now, if the boy walks 3 kilometers due east on the east, the boy walks how many kilometers? 3. So this is 3 kilometers, right? That is on the east. That is what I mean by due east. And then 4 kilometers due north. North is going up. So I'll go up. Okay. I will say 4 kilometers due north. What is the displacement of the boy from its original position? Then I will just have to join this place to the origin. That becomes the displacement of the boy, and this is what? X. Okay? Now, because it's a vector, certainly we are going to solve for direction, which is what? Theta. Okay? Now, we are going to use Pythagoras theorem to solve for this distance, which is x. Using Pythagoras theorem, this states that what? X, which is hypotenuse square, is equals to opposite square, which is 4 square, plus adjacent square, 3 square. Right? So what we are going to do is to say x square is equals to, what is 4 square? 4 square is 16 plus 3 square is what? 9. Now we can add them together by saying x square is equals to, when I add them, 16 plus 9, I'm going to have 25. So this is 25, right? So for me to get the s, which is the distance covered by this, but before talking about the direction, I'm going to take the roots of both sides by saying s square is equals to 25, roots of both sides. Sorry, if I take roots of both sides, this cancels this, okay, to be left with x, and this is root of 25. I'm going to have 5. So the answer to this question is 5 kilometers. This is just the distance covered from this boy to his original position. So I have 5 kilometers. Now, since it's a vector quantity, I was certainly going to solve for the direction. And for me to solve for direction, I'm going to use tan. That is trigonometry. I have SOHCAHTOA, but we prefer using tan for direction, in as much as it is a right angle vector, because this is a rectangle. So I'm going to use tan by saying tan theta. Remember that tan is opposite over adjacent, right? Now look at this angle. This side that is facing this angle is said to be opposite to this angle, while this other side is what? Adjacent to the angle. So my opposite becomes 4, while my adjacent becomes what? 3. Okay? I have tan theta is equals to 4 over 3. Tan theta is equals to, then I'm going to use my calculator to divide. 4 divided by 3, I'm going to have 1.33, right? Okay? Now, I'm looking for this theta, which is my direction. I'm going to say theta is equals to tan inverse of 1.33. Tan inverse, how you're going to press it in your calculator, just press shift tan, okay? Shift tan is going to give you tan inverse, which is this symbol, okay? Shift tan 1.33, I'm going to have 53.06 degrees, okay? So I've gotten this angle to be what? 53.001 degrees, sorry, okay? But there's one thing you must note. In direction, in as much as right angle vectors is concerned, we can't take direction from the horizontal. Don't forget that my theta is here. Okay, so I need the direction here, right? And this is right angle. And if I've gotten here to be 53.01 degrees, what should this one give us? I'm going to say 90 minus what I have to get this, right? So my direction is equals to 90 minus 53.01. Okay? So I'm going to use calculator to subtract 90 minus 53.01. Answer is going to give me 36.99 degrees, right? So my direction becomes not 36.99 degrees east, not 36.99 degrees what? East. Why did I have to subtract? Because I cannot take direction of a vector, because this is a vector quantity. I cannot take the direction of a vector from the horizontal component, which is horizontal, right? I must take it either from north or from what? South. And since I've gotten this angle to be 53.01 degrees, I need to subtract 90 from what I have to get the true what? Direction. So this is how you can solve for the displacement of an object, because it is a vector what? Quantity. So as far as I have gotten my magnitude, the next thing to do is to get the what? Direction. I hope you understand it. So this is how we can solve problem on displacement. Okay. Wow, thank you, Neka Juliet, for joining. I really appreciate. God bless you. Please give this video a thumbs up. I really appreciate. All right. Let me give you a small question to look up. Okay, let me solve another example so that you can understand better how we can do this. Okay, we have this question. A bus travels 5 kilometers due south and then 7 kilometers due west. Calculate the displacement of the bus. All right. Remember, you must not forget the 4 cardinal points. We have to draw it to be able to specify our question. Okay, so we have this. This is north, east, south, and what? West. If they say 5 kilometers due south, on the south I'm going to go down. Okay, so I have 5 kilometers and then 7 kilometers due west. And west is this way because this is west. I'm going to go this way. All right, that is 7 kilometers. Okay, the displacement of the ball from its original position, certainly this is where the ball started to move. Now from here to here, I'm going to get the distance, which is what? X, right? Then this is my right angle. I'm going to get what? My direction. Now I'm going to use Pythagoras theorem to solve. And Pythagoras theorem says that what? Hypotenuse square, hypotenuse is the longest side, is equals to opposite square plus what? Adjacent square. So if that is the case, I'm going to say x square is equals to 7 square plus 5 square, right? Okay, so x square is equals to, the square of 7 is going to give me 49 plus 25. Okay, so what do we have? So we are going to use our calculator to add 49 plus 25. So I have 74. Okay, then x is equals to, I'll just take the root of both sides to have what? 74. So root of 74 is going to give me 8.60 meters, right? This is my distance or magnitude, because a vector quantity has both magnitude and direction. Now, since we have gotten this, the next is for us to find the direction. And you're going to use direction using tan, like I told you before, that we're going to use tan. What is tan? Tan is opposite over what? Adjacent, right? This 7 is facing this angle, so it's said to be opposite to the angle. While this 5 is beside, it's said to be adjacent to the angle, right? So this is 7 over what? 5. Now I'm going to divide to say 7 divided by 5, I have 1.4, right? The next thing I'm going to do is to find the angle. So theta is equals to tan inverse of 1.4. I've told you how you're going to do the tan inverse with your calculator. Just press shift tan, right? That is your tan inverse. Okay, so we're going to say 1.4 is equals to 54.46 degrees. Now I have gotten this, right? Now there's something I told you earlier. I said that in direction, you're not going to take direction from the horizontal, and the horizontal comprises of the east and the what? The west. We are going to take direction from the vertical, and the vertical we have is what? South. So what do we do next? Now we have gotten this theta, which is already on the vertical, so we don't need to say 90 minus the angle obtained, because the theta already gotten is still on the vertical. I don't know if you understand. Let me explain it again. I said that peradventure this my angle happens to be here. After getting theta, it's not my true direction, because the angle is touching the horizontal, and we can't take any angle touching the horizontal. We need this one touching what? The vertical. But in this question now, my angle is now touching what? The vertical. So I don't need to subtract, because truly the angle is already in the right direction. So I will say my direction is equals to, or is, south 54.46 degree what? West. So my direction is equals to south 54.46 degree what? West. So this is how we can solve problem under displacement. I hope you enjoyed this class. Thank you so much for joining. Thank you so much for joining. Please, we have come to the end of this live stream and probably end of this class for today. If you have any question, you can drop in the comment section. If you have any topic, any whatever topic that you have challenges in physics that you want me to explain for you, just drop in the comment section. I will still come and make video and explain it very well the way you understand. Thank you so much for joining my live stream. I really appreciate. God bless you. We are going to end here. See you next time in the next one. Bye.